Hello everybody, welcome back to Maria Rich Math channel. In this channel, we will be doing prime factorization.
Hi everybody, what does it mean prime factorization? Yes, Maria, prime factorization.
Well, prime factorization means breaking a number down into radical.
So, prime factorization means breaking down a number into a set of prime numbers, which multiply together to get the original number. Okay, so once again, what does it mean, prime factorization? It means breaking down
a number,
breaking a number down
into
of a prime numbers into a set of numbers, yes, which
multiply together to get
we multiply together to get the original number, which multiply together to get the original number. Okay. In other words, we say prime factorization means
finding prime factors of a number.
Okay, it means finding the prime factors of a number. So prime factorization means finding, let me write it, finding, yes, Maria, finding what?
Finding prime factors of a number.
Prime factors of a number. Yes. Finding a prime factors of a number means prime factorization. And we said before that any integer or any integer number can be written as a multiplication of prime numbers. This is very important. And these prime numbers are called the prime factors of a number. Okay. So any integer, once again, write it, any integer, Maria.
Any integer.
Yes, any positive integer or any integer can be written
as a multiplication of prime numbers.
Can be written as a multiplication of prime numbers, as a multiplication of prime numbers. Let us see how. Okay. First of all, what are the prime number? What does it mean, a prime number, Maria?
Prime numbers. The prime numbers are 2, 3, 5, 7, 11, 13, and 17, and so on forever.
Okay, so prime numbers start from 2, 3, 5, 7, 11, 13, 17, and so on. What does it mean, prime number? What does it mean, prime number, Maria? Prime number is a number that can be divisible.
A number can be divisible by 1 and itself.
Okay, prime number means, let me write it here once again. This is prime number has only 2 divisors. Yes.
1 and itself.
1 and itself. Yeah. So 2 can be divided by 2 and by 1. 3 can be divided by 3 and by 1. 5 can be divided by 5 and by 1 as well. So any prime number has only 2 divisors, 1 and itself. Okay. So, and more than that, any integer can be written as a multiplication of prime numbers, okay? Let us see how can we find factorization. First of all, let me give for example, let us have an example. Suppose we have a 12, integer 12. 12 can be written as, Maria, 2.
12 can be written as
2 times 2 times 3. Now, we should not say 4 times 3. 4 is not a prime. So 2 is a prime. This is a prime number. And this is 2 prime as well. Yes. And the 3 is a prime as well. So 12 is written as a multiplication of a prime numbers. Now, this 2 is a prime factor, this 2 prime factor, and this 3 is a prime factor of 12. So it has a 3 prime factors, 2, 2, and 3. And also can be written like that because 2 and 2 is the same. We can write 2 to the power of 2 times 3. Okay? So any integer, for example, 12 can be written as multiplication of a prime numbers, or this is a 3 prime and this is power of a prime. Okay, 2 squared is power of 2 times 2. Yeah. Okay, now the question is how to factorize, how to write any integer as a multiplication of prime numbers. Okay, what is the method, Maria? So the method, how to write, so methodology or method. Now we can write how to, the question is how to write, yes, Maria, how to write any number as what? As a multiplication.
As a multiplication
Of
of
prime numbers. Or how to find prime factors of any integer. How to find, let me write it once again. How to find what? Prime factors of any integer. How to find prime factors of any integer? It's so easy by division. Yes? Let us give an example. Let us have 12, for example. We write like that, perpendicular line, and divide. 12 divided by 2. We divide by the smallest prime number. What is the smallest prime number? What is the smallest prime number? 2. 12 divided by 2.
12 divided by 2 is 6.
Now, 6 again is divided by the smallest number. Which one?
3.
Not 3. 3 is not. 2 and 3. 2 or 3?
2. I'm saying that.
Okay, 6 divided by 3. What is this? 3. And now 3 divisible by 3 is 1. And we stop here. Okay. So 12, therefore, can be written as 2 times 2 times 3, or we write it 2 squared times 3. Okay, Maria? So we start divide by the smallest prime number. The smallest prime number is 2, then 3, then and so on. Let us have one more example. How about 18? We write like that, perpendicular line. Then 18 is divisible by 2 and divisible by 3 as well. Why 18 is divisible by 3? Because 8 plus 1 is 9, so 9 is divisible by 3. So the sum of its digits divisible by 3. But we have to divide by the smallest prime number. What is the smallest prime number?
2.
2. 18 divided by 2 is 9. 9 now is divisible by 3. We find the smallest prime number. 3. 9 divided by 3 is 3, and now 3 divisible by 3 is 1. So therefore, 18 can be written as 2 times 3 times 3. Yes, or 2 times 3 squared. Okay. One more example, Maria. 36. For example, 36. We have to divide it by the smallest prime number, and so on. Yes, 3 divided by 2, that's 1.
1.
The remaining 1, 16 divided by 2 is 8. 18 divisible by 2 is 9. 9 is divisible by 3. The result 3. 3 is divisible by 3, 1. Therefore, we write 36. 2 times 2 times the 3 times the 3. And these are 2 squared times the 3 squared. And this 2 is a prime, this 2 is a prime, this 3 is a prime, this 3 is a prime. And here is power of prime, this is power of prime. Okay? So every integer can be written as a multiplication of a prime numbers. Okay, how about, for example, 17? 17 is a prime number. It's a prime, we can write it 17, 1 times 17. How about 11? 11 is 1 times 11. Okay, 23 is a 23, 1 times 23. So it is the same, it's written prime number. And 1, as we said, is a prime number, but it's okay. We don't consider it, so we can consider that we can write 23 multiplied by 1, and we consider it here as a prime. So any integer still can be written as a multiplication of prime numbers. Yeah. So we have to start. We divide by the smallest start number, smallest prime number. What do we have now here? Let me give me an example. 180. Okay, well, Maria, 180. How we do it? Divide y by 2, because any number ends in 0 or an even number 2, 4, 6, 8, and so on. That's divisible by 2. 18 divided by 2, it is
90.
90. Now 90 also divisible by 2. 9 divided by 2 is 4.
45.
And still 1. 10 divided by 2 is 5. 45. 45 is divisible by, let us see, it's not divisible by 2. Now we have to check the second prime number. Second prime number, we have 2, then 3, then 5, then 7, then 11, and so on. So what is the second one? 3. Does is 45 divisible by 3?
Yes.
Yes. Why? Because 4 plus 5 is 9, so 9 is divisible by 3, so 55 divisible by 3. 5 divided by 3 is 1, remaining is 1, 15 divided by 3 is 3, yeah? Or 5. 5, 15 divided by 3, 5. Now, 15 is also again divisible by 3. Yes? It's 5. And then 5 by 5 is 1. That we are done. So therefore, Maria, therefore 180 equals, we can write it 2
equals 2
squared times 3 squared times 5. So this is prime, and this is 3 prime and 5 prime, and this is 2 to the squared is a prime factor, and this is prime factors also, and 5 also is a prime number, and this is power. 2 to the square is power of prime, 3 squared is power of prime. Okay. One more example.
500.
Yeah, just a second. Keep. Let me write one more. Insert slide. One more slide. Blank slide. Yes, Maria. Let us have one more example. Yes. Here. What is the example? 500.
512.
512. Okay, we draw like that. So divisible by 2.
Which equals 256.
256. Divisible by 2 as well.
Equals
1. 128. Divisible by 2, Maria.
64.
Divisible by 2.
32.
Divisible by 2.
16.
16. Divided by 2.
8.
8 divided by 2.
4.
4 divided by 2.
2.
2 divided by 2. 1. So let us count them: 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, 512 can be written as 2 to the power of 9. 2 is a prime, and 2 to the power of 9 is power of prime. Okay. And how about if I ask you 1024, Maria? You can write it like that. At 1024, it's divided by 2, it will be 10 divided by 2, 5, 2 divided by 2, 4. And so see here,
1024 equals 2
and
tens.
and yeah, and we have here, as you see, 512, and we can repeat the same. So it is 9 here, and 1 here will be 10. So therefore, we can write 1024 equals 2 to the power of 10 to the 10th. Why? Because here to the 9th, and as you see, one more 2, so 2 to the 10th. Yeah. Okay. Repeat the same what we have today. Yes, Maria.
Maria Rich Math Channel.
Yeah.
Prime factorization.
Yeah. What does it mean, prime factorization of a number?
Breaking a number down into a set of prime numbers which multiply together to get the original
number. In other words, we can say finding
prime factors of a number. Any integer can be written as a multiplication of prime numbers.
Any integer can be written as a multiplication of prime numbers or a prime power of prime numbers as well. Okay. So prime numbers, as you know, 2, 3, 5, 7, blah, blah, blah. What does it mean, prime number, Maria?
Prime number has only 2 divisors, 1 in itself.
So any prime number can be divisible by 1 and by itself. So any prime number has only 2 divisors, 1 and itself, as you see, 2, 3, 5, 7, and so on. And any integer like 12, for example, can be written as 2 times 2 times 3. So 2 is a prime, 2 is a prime, 3 is a prime. So this is integer can be written as 3 prime numbers. But 2 times 2, it is 2 squared. Okay, and we can say 12 is written as a multiplication of prime or power of a prime. 2 to the 2 power of prime. Okay. How to write now a number as multiplication of prime numbers, or how to find the prime factors of an integer, Maria? How to find the prime factors of an integer? By division.
By division.
We divided 12 by
12 divided by 2 is 6, 6 divided by 2 is 3, 3 divided by 3 is 1. 12 equals 2 times 2 times 3 equals 2 squared times 3.
Yes, so we have to search for the smallest prime number, which is the number which is given number is divisible by 2. If not, so we go to the second one, 3, and then to 5, and so on. Here 18 divisible by 2, and 2 is a prime, then 9. It's 9. 9 is not divisible by 2, so we search for the second prime number, which is 9 is divisible by. It is a 3. 3, again 3 divisible by 3 is 1, so 18 equals 2 times 3 times 3 equals 2 times the 3 squared. How about 36, Maria? Also the same method. As you see, we have divided 33 by 2, then by 2, then by 3, then by 3. We got 33 equals 2 times 2 times 3 times 3 equals 2 squared times 3 squared. And these two are prime, 2 prime, 3 prime, and 2 to the power 2, it's we say power, prime power, prime power of a prime number. Okay. Once again, every number, every integer can be written as a multiplication of prime numbers or a multiplication of power of prime numbers. Okay, like here again. What if we have 17 or 11 or 23? In this case, the given number, it's itself prime number. So can be written as 1 times 17, 1 times 11, or 1 times 23. Okay. Here, the last two examples, we have given 512, and we got 512, it's power 2 to the 9th power, so to the 9, or 2 power of 9. And 1024, it's 2 to the 10th, or 2 power 10. as you see. So also it can be written as a prime number, a multiplication prime number, or power of prime number. Okay. Yeah, thank you.
Thank you very much. If you can please subscribe and like to our video. Have a good day, like morning, evening, afternoon.
Thank you.
Or night.
Okay,
Bye.
bye. Thanks.